Bearings are parts of machines that support especially the turning parts of machines. We can classify them into plain bearings that comprise just a bearing surface, and secondly to rolling bearings with rolling elements that help to reduce friction. There are 5 types of rolling elements used: balls, cylindrical rollers, tapered rollers, spherical rollers, and needles. Bearings can be also classified according to types of motions and loads they support into first thrust bearings. They support axial loads, and radial bearings that support loads that are perpendicular to the axis of rotation. In picture A, in this task, there is a double row ball bearing. It has inner and outer races between which 2 rows of balls roll. Each race features a groove, usually shaped so the ball fits slightly loose. In picture 2, we can see a double row cylindrical roller bearing. Cylinders' length is slightly greater than their diameter. In picture 3, there is a single row needle roller bearing. Needle roller bearings are used because they are very long and thin. As the rollers are thin, the outside diameter of the bearing is only slightly larger than the hole in the middle. However, the small diameter rollers must be bent sharply where they contact the races, and thus the bearing acts relatively quickly. In picture 4, we can see a double row tapered roller bearing. Tapered roller bearings use conical rollers that run on conical races. Most roller bearings only take radial or axial loads, but tapered roller bearings support both radial and axial loads, and generally can carry higher loads than ball bearings due to greater contact area. Tapered roller bearings are used, for example, as the wheel bearings of most wheeled land vehicles. In picture 5, there is a double row spherical roller bearing that has an outer ring with an internal spherical shape. The rollers are thicker in the middle and thinner at the ends. Spherical roller bearings can thus accommodate both static and dynamic misalignment. However, spherical rollers are difficult to produce, and so they are expensive, and the bearings have higher friction than an ideal cylindrical or tapered roller bearing, as there is a certain amount of sliding between roller elements and the rings.